Two blocks with masses m1 equals 2.9 kilograms and m2 equals 3 kilograms are at rest on a frictionless surface with a compressed spring between them. The spring is initially compressed by 59 centimeters and has negligible mass. When both blocks are released simultaneously and the spring has dropped to the surface, m1 is found to have a speed of 2.3 meters per second. What is the speed of m2 and what is the spring constant of the spring? So for the first part of the question, they want the speed of m2, and I'm going to use the conservation of momentum equation for this, which states that the mass times the volume of the initial system should be equal to the mass times the volume of the final system. So the initial system would be mass 1 times its velocity plus mass 2 times its velocity, and the final momentum of the system would be mass 1 times the final velocity plus mass 2 times its final velocity. So let's plug numbers in from the question into this equation. Mass 1 is 2.9, and since both blocks are initially at rest, the initial velocity will be 0, plus mass 2, which they tell us is 3 kilograms, times its velocity, which is 0 because it's at rest. Then for the final momentum, the mass of block 1 is 2.9 times its velocity, final velocity, which they tell us is 2.3 meters per second, plus mass 2, which is 3, times the velocity of mass 2, which they asked us to find. So this 2.9 times 0 is 0, 3 times 0 is 0, 2.9 times 2.3 is 6.67, plus 3v. Subtract this over to the other side to solve for v. And I'm just going to take the absolute value of v. So when we solve for this, we find v equals 2.223 meters per second. The second part of the question asks for the spring constant of the spring, and for this I'm going to use the kinetic energy and potential energy equations. So in this problem, the kinetic energy of mass 1 plus the kinetic energy of mass 2 should equal the total energy of the whole system. And total energy of a spring system, total energy of a spring system is the potential energy in the spring, which is 1/2 kx squared. So this k is what we're looking for in this part of the question, the spring constant. So kinetic energy is 1/2 mv squared equal to 1/2 kx squared. So 1/2 times the mass of block 1, 2.9, times the final velocity of block 1, 2.3, squared, plus 1/2 times the mass of block 2 times the final velocity of block 2, squared, should equal 1/2 kx squared. So this is 7.6705. This is 7.4126, and 1/2 k, they gave us x over here, 59 centimeters. It's compressed by 59 centimeters. I'm going to convert that to meters, so that is 0.59 meters squared. The sum of these two is equal to 15.0831 equals 1/2 k.59 squared. And from here it's pretty simple to simplify for k, which we find to equal 86.66 newtons per meter.